I'm Seth.
I'm Kennedy.
So this is a red dye, and this is an egg. These are all molecules, and what it wants to do, this is concentration gradient. It wants to get to equilibrium, so it diffuses the concentration gradient into equilibrium.
All right. Our hypothesis was that the faster that we stirred it, then it would be more mechanism in the middle.
Our independent variable was the stirring. Our dependent variable was how fast it will turn the egg red. Our control variables were the water, the food dye, and the beaker.
Our control group was speed 0 because it wasn't stirring at all. Our first experimental group was set at speed 1, so it was stirring a little bit, but not very fast. And then our second experimental group was set at speed 3, so it was stirring faster than speed 1.
Okay. And our conclusion was that the one that was stirred the most was more expansive in the middle, because speed 0 is still a little bit down the middle. Speed 1 is in between these two, and then speed 3 is went all the way through.
The reason why we got these results was because the faster you stir it, the more it would mix in with the egg, and it would get to the center of the egg.
And what we could have done to make this experiment better was to set it for times, because all three of these are really similar. So if we had it set at a different time for how fast it was stirring, we could tell if it was better or not by the color in the middle.
Brad.
Donovan. Christian.
Okay. Some background information on our experiment was we tested if the molecule size was bigger in blue and yellow and stuff. In different food colorings, molecule sizes are bigger and smaller and everything else. So our background information is molecules, when smaller, can diffuse way faster than when bigger molecules can. And they all want to reach equilibrium from when we put the egg in the solution.
So our hypothesis was that the smaller particle we have will diffuse better throughout the egg.
The independent variable is the molecule size. Independent is the amount of travel. Controlled is the amount of light, water, temp. The control was the red. The experimental was the blue and yellow because of the different molecule size.
Okay, so blue was the worst because it had bigger particles and it didn't diffuse through the egg. And then red and yellow were about the same, so they had about the same diffusion.
Yeah, pretty much just like Nick just said. Blue was worse because it had the biggest molecule, or so 92. And since red and yellow were so close, they were 38 apart. Since they were so close, we couldn't really tell which one was better and which one was worse. And the thing that could make our experiment better was to take a bunch of different colors and with a bunch of different molecule sizes and see which one would diffuse the best. The bigger eggs.
Hi, I'm Tristan. I'm Anna. I'm Lizzie.
I'm all played up.
We tested how heat or how temperature will affect the coloring getting to the middle of an egg. We have equilibrium, which is equal on both sides of the cell, and we have concentration gradient, which is different on both sides. And diffusion is going from concentration gradient to equilibrium. In our project or experiment, the solution is water, and the coloring is trying to get to equilibrium into the egg and the water. Our hypothesis was that heat will have the most food coloring in the middle of the egg, and the cold will not.
Our hypothesis was correct. The egg that was in the heated area had more dye in it, while the cold had less.
Our independent variable was the amount of heat. Our dependent variable was how far the food coloring got to the middle of the egg, and our control variables were the size of egg, the beaker size, the amount of water, and the amount of food coloring.
Our control group was number 2 because it was just the regular temperature. And so, our best one was the hot water because, hot water makes molecules move faster. And
our cold one was the worst because the molecules were slower, so there was like a little more light to it.
Okay, so our heated egg had more food dye in it, because as we know from equation number 2 of the heat moves the substrate quicker, which will make it go into an enzyme's active site. And so they had more, and the one in the cold area did not, because they did not have enough heat to get the active site.
What we could have done to make this better is we probably could have used colder temperatures or hotter temperatures. And then get like different.
I'm Ben.
I'm Xavier.
I'm Brandon.
I'm Lucas.
Okay, so the definition of diffusion is it all starts out as a concentration gradient, and then over time it'll all be equilibrium. So concentration gradient is when the particles are all on one side and there's a small amount or none on the other, but then it will all be equal on both sides. So what happened in or how I could put this with our experiment is the red food coloring is the concentration gradient, and same with the white egg. And then once it all dyes together, then it's equilibrium.
And if we have a smaller sized egg, then the diffusion will happen faster. Because if we have a bigger chunk of an egg, then it will go slower.
Our independent variable was the size of the egg. Our dependent variable was how fast the food coloring would get to the center. And our control variables were the diameter water and the glass.
And the thing that we changed was the size of the egg. In our control group, we had a medium-sized chunk of egg. And then in our experiment group 1, we had a small chunk of egg. And then in experiment group 2, we had a large chunk of egg.
So our hypothesis was that the small would reach or would be equal or have equilibrium a lot more than the other eggs, which that actually was the case because our results was that the small actually did go all the way into equilibrium, but the large, there's a little bit of white right there, and that shows that it didn't get all the way, so it's kind of concentration gradient.
In conclusion, our results were what we wanted because there was a smaller distance that made it get to a diffuse faster.
Some things we could have done differently is one, we could have more periodically checked how fast it took to diffuse the egg. So we could have been able to tell how efficient it was diffused, or we could have cut up more different sizes of egg to see just which one was the most efficient in diffusion.
I'm Cheyenne. I'm Haley. I'm Cameron. I'm Amy. And the experiment we did was on diffusion, which diffusion is when you have a concentration gradient, which means it's unequal. And nature likes it to be equal, so by diffusion, it moves the particles to the equal side. Our hypothesis was that the more dye you added into the solution, the quicker diffusion would occur.
Our independent variable would be the amount of food coloring we put in the water, and our dependent variable would be how fast the diffusion worked. And our control would be the type of food coloring, the type of egg, and the quantities.
The control and experiment groups, the control was the 0.5, and then the experimentals were 0.4 and 0.6 of red food coloring, and the results were what our hypothesis was, which would be that the more food coloring we put in there, the faster diffusion would take place. So our hypothesis was correct. Our first group had the best results because it had the most food coloring. Our second group had the least, which was our worst results. And our control group was a close second to the first.
thing we could change was make the eggs more like the size equal.